Hi all. My name is Dharani Tejaswini. I am a PhD student working in Center for IT in Building Science, IIIT Hyderabad, India. I'm here to present the paper titled Residential Electricity Current and Appliance Dataset for AC Event Detection from Indian Dwellings. So I want to start by saying that the residential sector in India is among the major contributors of energy. The population in India is also increasing rapidly. It has uh, led to the access of affordable and reliable energy, thereby increasing energy demand. The International Energy Agency has also pointed out that ACs contribute to a major percentage of the total electricity consumption. It has also projected that the purchase of residential AC units will increase from 63 million units in 2020 to approximately 1144 million units by 2050. Therefore, there is a need for AC energy monitoring that will help us determine how much AC's consumption is happening and how much it contributes to the overall household electricity consumption. It also helps in identifying and analyzing the AC usage patterns that can help in identifying energy savings potential. However, the individual AC monitoring for each home would require additional investment in order to build the hardware for submetering, and also it requires reliable communication channels so that you can collect the data from multiple submeters and store it in the server for analysis. Therefore, the concept of NILM has come into picture. NILM non-intrusive load monitoring attempts to solve this problem by utilizing data from the meter level loggers, and we try to apply disaggregation algorithms that will classify the individual appliances based on the load signatures. Researchers require access to data sets recorded in the field to develop, train, and test these algorithms. Since it is not feasible for every researcher to record their own dataset, the creation of open access datasets to promote NLM research is very helpful. There are already existing datasets like RED, UKDL, Refit that are from UK, AMPDS, and RAE, which are publicly available and they are from Canada. We also have Greenly, that is from Italy, Eco from Switzerland, DRED from Holland, Enatalk from Korea. The availability of such diverse datasets will help researchers understand electricity and appliance usage patterns from different countries. Usage patterns vary across countries mainly because of the difference in occupancy comfort, lifestyle, and outdoor weather conditions. Therefore, for a tropical country like India, energy datasets like iBlend, Combed, and IAW are available. iBlend and Combed are generally building level datasets, so they have data for 52 months from 6 to 7 commercial buildings, and they contain energy utilized by transformers, chillers, UPS, and lifts. So it doesn't have AC energy consumption individually. We have another dataset called IAWE that has recorded appliance data for one home for around 73 days. So of the so this is where we were motivated because from the available aggregated data sets that are present, those that have claimed that they have AC load disaggregation, there's only one dataset IAWE that is from India, and also this dataset has ground truth for 10 appliances from a single home. Therefore, we felt that there is a need for a larger dataset with more homes and also with diverse usage in AC types. So we have split AC type and inverter AC type. Our dataset that we have contains data from around 11 homes from a city in India with composite climate, that is Hyderabad, and the data is collected for almost 19 days. We have electricity data with at 1 minute interval, and we have temperature humidity data at 5 minute interval. So the entire dataset consists of 1.6 million data points and around 450 AC cycles, and each AC cycles contain more than 2000 compressor on-off cycles. The dataset has 7 parameters, that is timestamp. It has all the 3-phase currents, AC status, temperature and humidity. Additionally, we also have the survey and weather data, which is also part of the dataset. So we've collected the data. The process in which we've collected the data is shown in the figure. We had a mobile application that was developed. The mobile app connects to Garud and NVLog loggers, that are current and temperature loggers, and the application will collect the data from the loggers and upload it to the database server using Wi-Fi or cellular networks. A web application has been designed to view the data uploaded to the database server. So the web applications looks like this. It also facilitates report generation, providing details of per house energy consumption on a daily, weekly, and monthly basis. So this is how our Karur looks like. It has 3 CTs present in it, and each of the CTs goes on to each phase. And if it is a single phase current, we'll use only one CT. Other than that, we also have NVLog, where we install it in the room with the AC. Also, an Android mobile was developed, as told in the previous slide, to manage the homes that were under survey and upload the data to the files. We use Bluetooth to transfer the data from the loggers to the app, and from the app we use Wi-Fi or LTE to transfer it to the server. So this is what our dataset contains. Each Garud file contains 5 fields. One is the datetime field, which has IST, that is the Indian Standard Time, and you can convert it to UTC by subtracting it by 530 hours. We also have the house ID, that is used as a key to identify each home uniquely. Other than that, we have the 3-phase current columns represented by R, Y and B, red, yellow, blue. And we have the AC status that talks about the on-off status of the AC. 0 stands for off and 1 stands for on. Other than that, we have also the NVLog field, which talks about the date time, temperature and relative humidity that is captured at a 5-minute interval of the AC room. We have survey data that consists of building details, AC details, dwelling details and weather data. Building details talks about the type of dwelling, number of rooms, age of the building, etc. AC details talk about where the AC is, which room the AC is installed, the phase on which the AC is connected, AC set point, primary AC tonnage, and so on. So in Indian homes, majority of the ACs are present as individual units in the bedroom or in the living rooms or in both locations, in contrast to the centralized AC systems that are common in the West. Generally, the average size of the bedroom where the AC is present is 20 square meters. Along with this, we also have the dwelling data, which talks about the number of occupants, the income group of the people living, the number of phases, the type of appliances they had, and so on. Along with that, we also had the weather data, outdoor data, which holds the temperature and humidity values. Now, in order to validate and check if whatever data we've captured is correct or not, we had to compare our readings with a standard meter. So to validate that logging system is running as expected, we ran several test routines to check these. One test we had conducted was we checked that the electricity consumption values captured by Garud are similar to values observed in the monthly electricity bills. So though this data set is of 19 days, we had actually collected 1 year current data, and we compared the monthly electricity bills with our Garud 1 monthly average data. So before deployment also, we've checked the device's data for precision by testing it against accurate standard meters. One meter we've used is Yokogawa WT330 for laboratory reference, and the other one is Watnor WNC, and it was used as a field reference meter. The experiment was conducted by varying the load connected across Garud and the 2 standard meters. We varied the current between 100 milliamperes to 12 amperes, and you can see that the correlation is very near. Similarly, we've performed a similar test for NVlog to check if the temperature and humidity values are in sync with the standard devices like iButton and Hobo. We've placed the sensors inside a box and we've varied the temperatures by changing the set point of the AC. We vary the temperature between 19 degrees Celsius and 30 degrees Celsius, and the temperature graph shows almost an accurate reading, whereas the relative humidity shows almost like 1 to -1% error. Thank you. If you have any queries, you can contact me at the given mail ID.